Now, what makes a system of equations a system of equations? It's multiple. We'll get to more than two, but it is, yes, multiple equations, and you're asked to find the solution. So before we get to solving these algebraically using substitution and elimination, I want us to take a look at this system on a graph. Now today is just linear systems. We're just doing linear, meaning the x isn't squared. It's just a plain x. So this first equation you see, is that immediately graphable? Yeah, right? Y equals 3x plus 2. It's in slope-intercept form. So let's go ahead and graph that. Where should I put my first perfect point? Yes. So it was, what was it again? It was y equals 3x plus 2. So the plus 2 tells me I graph it, my first perfect point at 0, 2. Now what is my slope for this line? 3x, or just 3. The slope is 3. So where do I go from that perfect point?
Up 3 over 1.
Up 3, which way 1?
That way 1.
Good, to the positive direction, to the right one. Up 3 over 1. Up 3 over 1. Down 3 to the left one. Down 3 to the left one. Shh. So here's my line. This is the line y equals 3x plus 2. I should probably have made you graph these, seeing as how rough a time you had on the test graphing. Okay, this next equation, I'll go back. This next equation, is it immediately graphable? No. What do I need to do? I have to put, whoa. I have to put it in slope-intercept form. Do not just put this in the calculator. What do I do to it?
You have to bring the y to itself.
I have to try to get the y all by itself. Good. So I'm going to first add 4x over. Can the 8 and the 4x be combined?
No.
No. And then what do I do? Divide both sides by 2. So my equation is y equals 2x plus 4. Is this now graphable?
Yeah.
Oh, good. Where should I put my first point?
4.
Good, at 4. At y is 4. So that's 0, 4. And my slope is how much? 2 over 1. So my rise is 2, and my run is 1. So I go up 2 over 1, up 2 over 1, down 2 to the left 1, down 2 to the left 1. So this is my line. Just erase a 1. There we go. All right. So this is the line y equal, well, I'll do the original, but oh my. I'll do the original. What was it? Negative 4x plus 2y equals 8?
Yeah.
Negative 4x plus 2y equals 8?
Yes.
Why do you think I had you graph these?
Because that way we can actually see the intersection.
Oh, what do you think the intersection is?
The solution.
Oh my gosh. It is the solution between these two lines. So, at what x value do they intercept? At 2. At what y value do they intercept? That is our solution to this system. So yes, if on the test you're asked to solve a system by substitution, you can check your answer by looking at the graph. That's how you would check your answer.
Are we not going to use calculators all year?
No, this unit you are allowed to use calculators.
So we can just put that on our calculator.
But on the test it'll say solve by substitution. Then no, you have to solve it algebraically. So now I'm going to show you the two ways that you can solve algebraically. One is substitution, the other is elimination. Substitution, I believe that you have had exposure to. Maybe some of you have had exposure to elimination as well. We'll see. So first, I want you to rewrite the two equations. What were they? Y equals 3x plus 2. And negative 4x plus 2y equals 8. So this is in the substitution. What do you think substitution is going to entail?
You're gonna find the y value and then plug it back in for the other, like, original.
Okay. So the one stipulation for substitution is that you get one of the variables all by itself. Do we have one of the variables all by itself?
Yes.
Which one?
Y.
Oh, we have y all by itself. Meaning that wherever we see a y in the second equation, I can plug in what y is equal to. So here, y is equal to 3x plus 2. That means wherever we see the y, what are we going to replace? Good. And what am I going to put around my substitution? Perfect, yes. So, now what do you do? Well, first of all, wait, hold on. Hold on. Let's think about this. Why did I just do that? Why can I now solve this? Now I only have one variable. Can I solve an equation with one variable? Oh, you better bet. So, what do? First, you distribute the 2. Good. Hold up. You gotta get there. And now what do? Oh, you come up. So what did we say to do next? From here? Combine your like terms. Your minus 4x and your plus 6x. And you get plus 4 equals 8. Then what? Good. Subtract 4 over. So you get 2x is 4. And then you divide by 2. X equals 2. Good. I said change the color and it didn't. There it goes. Okay. So is that not what we got when we looked at the graph?
Yes.
Didn't we get a solution that had an x value of 2?
Yes.
Yes. Am I done?
No.
Why am I not done?
Because you still have to solve for y.
Oh, I still need to figure out what y is. So over here I'm going to solve for y. How do I solve for y? Now, which one do you think is going to be easier to plug x back into? Right. If we plug x into the top one, we'll immediately get y right there. So we have y is equal to 3 times, what do I put in for x now? Good. And what is 3 times 2?
6.
And what is 6 plus 2? 8. So I got a y value of 8. So my coordinates of my solution are what?
At 2,
2, 8. This is what I'm looking for. A coordinate point, right? You're looking for where these two lines intersect. Yes, we're solving algebraically, but you still need to give me the point. Yes. Yeah. Any other questions on substitution? Most of you have probably seen this before. Elimination is where it gets a little, not tricky, just different. So again, I want you to write the equations. Y equals 3x plus 2 and negative 4x plus 2y is equal to 8. What do you think our goal is if this process is called elimination? You're trying to eliminate one of the variables, so you're left with just an equation with one variable that you can solve. So the stipulation for elimination is that everything needs to be lined up. Your y's need to be lined up, your x's lined up, and your constants lined up. Are they lined up in this problem? No. So that's probably what makes substitution easier on this problem. So, oh, I'm going to move this over. I'm sorry if you just wrote it in the center. It's fine. You can leave it. So, I am going to rearrange. Which one would you like me to change?
The bottom one.
The bottom one? Okay. It doesn't matter, really.
The bottom one, you just have to flip. You just make it 2x minus 2y minus 4x. And then it'll.
Okay, so the equal sign also needs to be lined up. Equal sign also need, good, I'm glad you made that little mistake there. The equal sign needs to be in the same place. So
then add 4x.
Okay, yes, I would add 4x over. So I add 4x. And this becomes 2y equals 4x plus 8. And I'm just going to move the top over, keeping it in the same position. So now is everything lined up? Yes. Oh. I should have stuck with how I did it before, because now it's tricky. Not really. We'll just do it, and I'll explain. So I need to multiply either the top or the bottom by something that will make, when I add these together, that will make that variable cancel out. So which one do you think I can multiply? 2. So if I multiply this top one by 2, that'll make this 2y. Does 2y plus 2y cancel out?
No.
So what should I instead multiply by? Negative 2. Multiply both by negative 2. So this entire top, I'm going to multiply by negative 2. It becomes negative 2y equals negative 6x minus 4. And then I just bring down the bottom, keeping it the same. And I add these two equations together. So what is negative 2y plus 2i? What is it? 0. They cancel. That's how I know I did the elimination process correct. They canceled out. So I have a 0 over here. What is negative 6x plus 4? And negative 4 plus 8? 4. So this is why maybe in the beginning I would have instead moved the 3x over, subtracted the 3x, because you're left with a 0 on the side, which is fine. But I now just need to add 2x over to get it by itself. So I'm going to add 2x. So I have 2x equals 4. And then I divide by 2. And what's x? X is 2. Is that what we got in the previous problems? The previous examples? Yes.
So when you do the elimination thing and you cancel it out, does it cancel out the y too, not just the 2?
Yes. Yes. Am I done? Oh, I again have to plug in and solve for y. So I'm going to plug 2 into which one?
The
the top one, the easy one. Y equals 3. And I put 2 in this time for x. 3 times 2 is 6, plus 2 is 8. And that's what I got before. The coordinates of my point are again 2, 8. So clearly on this problem, elimination probably wasn't the way to go, just because they weren't already lined up. But if you take a look on the back, look at these two equations. What do you notice immediately? Oh my gosh. And they already do what? They already eliminate. Boom, it's already set up. This is where elimination is easier. Okay? This is where elimination is easier and substitution isn't so great. I want you to try to graph, use substitution and elimination on this problem. Go ahead. Any questions on elimination, by the way? Okay.